Now we apply the section method to compute the internal forces. So assume we have no internal forces and we have section 1, section 1 here divides our truss into two parts, a left part and a part right to the section. We can compute from any convenient part. Here, we consider the left part, the part left to the section, S1, S1, or section 1, 1, with all the external forces and all the internal forces that had a cut passing through the considered members. So, FGC is analyzed into two components, FGC cosine 45 and FGC sine 45. And we start with our first equilibrium equation, sigma forces in the y direction equals 0. In the y direction, we have the 6 tons heading upwards and 4 tons FGC sine 45 heading downwards. So they have an opposite direction. This gives FGC 2.82 tons, having a positive sign, which means that we assume the tension force correctly and is plotted on our diagram. Taking sigma moments about C, we will compute FDE. Note that FGC and FAC pass through C and therefore they do not appear in the equation about C as they have no arm with the joint C. Of course, we will consider the external forces 6 tons and 4 tons. So we have 6 tons rotating clockwise about C and considering this direction to be positive. You can of course assume it a negative and continue. We assume it here to be a positive sign. And since 4 tons is rotating counterclockwise about C, it will take an opposite sign or a negative sign. 4 tons multiplied by the arm to reach C. Please recall that the arm of the force is the distance or the length between the joint about the moment is taken and perpendicular to the force. So FDE rotates clockwise also about C, and the arm from C is the vertical 3 meters perpendicular to DE. This gives DE to be minus 2 tons compression and is plotted on our diagram. Sigma forces in the x direction equals 0. We have all forces, all 1, 2, 3 forces in the x direction equals 0. We substitute for the value of DE and DC by the previously computed values, and we are left with the only unknown FAC to be 0 tons and is plotted on our diagram. Now we need joint A to compute the internal force in AD. As previously explained, we extract the joint A outside with all external and internal forces connected to the joint, and we take sigma forces in the y direction to compute AD to be minus 6 tons compression force, and we take the last joint E here extracted outside with the 4 tons and the internal forces in the 3 members connected to joint E. we are really concerned with the vertical force EC, as ED, the horizontal force, is previously computed. And therefore, we take sigma forces in the y direction to be equal to 0, and we get the force in CE or EC equals minus 4 tons compression force. A detailed joint method was demonstrated before this explanation of the section method.